Hello, everybody. Thanks for tuning in. My name is Val. I'm the CTO of Uber Freight, and we'll talk about learnings that we've accumulated trying to adopt artificial intelligence in logistics industry. Logistics is something that probably all of you have come really close in the last couple of years during COVID, where we had backed up ports, we couldn't find trucks, there was no toilet paper, and people basically couldn't get anything. I think it's pretty clear realization how crucial it is to our survival and just general well-being. So if I were to characterize logistics industry, I would just use the words complicated and disjointed. And our mission is to bring transparency and ease with people to transpose logistical problems into just logical things that you can actually solve. We're excited about this new and rather newly popular technology, and in Uber Freight and Uber, we've been using artificial intelligence for a few years now. We've been pushing on that for dynamic pricing, digital marketplace, routing, customer service, and many other industrial applications. But typically, there were barriers where we could not gain enough of the context, enough of the understanding of outside world to truly solve them on massive scale. And also, it was pretty hard to fit all that into a regular envelope of compute and data that systems are capable of running in economic means. So, of course, a year and change ago, when OpenAI came out with ChatGPT, a lot of those barriers have been removed. And it totally helped us accelerate what it is we do. So I'll start highlighting what we do and why do we do that, and then we move on to some examples of how do we actually proceed there. So Uber Freight is the third largest member of Uber family. We are running $18 billion worth of freight through multiple countries, with many, many different customers, supported by 2 million carriers, 2 million drivers, and 27 million transactions on an annual basis. We offer a wide variety of services that we call relational logistics, that basically is comprised of various products and services that allow supply chain to function, be more efficient, and optimize for particular goals that our customers desire, and those could be many. In order to increase efficiency and transparency of logistics, we try to distill the data, again, into more and more meaningful tasks. And ultimately, logistics powers anything that you see around you. And I really mean anything, because like anything in this room, anything you're wearing has been on a truck at one point of its lifetime before it got to you. One of our biggest challenges is to create visibility and thank you so much. And understand performance of the transportation network, and then allow it to optimize it based on our customers' needs. Some people want to optimize for cost. Some people want to optimize for speed. Some people want to optimize for resiliency. Lately, a lot of people think about environmental impact of what they transport, and that's also important. So in this particular example, one of our tools is actually giving that answer. So to address those challenges, we embarked on building a system called Insights AI. Talking to our customers and just understanding the industrial challenges, our goals were to build a system that is smart. It is data-driven to enable smart decision-making process, predictive and prescriptive, where we want to empower, and we actually have been successfully doing that, empower our users to not only understand the challenges of the industry, but also be advised what's the right decision they need to make, what's the right action they need to take to improve their performance. And of course, need to answer questions with wide variety of complexity. And we would like people to be able to use free-form language to do so, as opposed to navigate traditional transportation management tools that are like super complex, and they usually look like 80s software that Stephen Wolfram probably wrote at one point in time. System needs to be knowledgeable, and we need to pull data from multiple data sources. It's important to provide information, transportation prices, fuel prices, congestion, weather, inventory levels, but all of that needs to be distilled in something useful. And understanding nuances of a specific customer, specific actor you're talking to is very, very important, because if two people will ask the same question, people from different company, you could get a completely different result. Their meaning is going to be something completely different, so we'll get a little bit to it. When we do produce results, in order for people to believe in this technology, we would like to accompany our answers with explanations and evidence to build the trust over time. System requires very clear and very strict data governance and quality to avoid garbage in and garbage out use cases, and we need to control hallucinations. So in order to solve those problems, we decided to partition the system that would then mimic the actions of a human analyst into multiple phases. And each phase is powered by a fine-tuned LLM agent, and they're all fine-tuned in their own way. The reason we are using fine-tuning is because general models, while they're really, really good at traditional question and answer, when they run into industry specifics, they do not have that knowledge. So ability to connect the foundational data to industry jargon, abbreviations, specific definitions, specific formula that customers may employ is something that needs to be created for the system to actually function end-to-end. So if you break it down into phases, first, we need to understand the actual question that's being asked to really distill the context. Who is talking? What is it they're looking to do? Based on their previous history of asking questions, what do they actually mean? We build the context around it, transposing their question into, and we'll go into a little bit more details down the road, transposing that into ability to reach the right corners of our data set and interpret it accordingly. Then the data needs to be synthesized and then reported back to the user while undergoing hallucination control and validation. So it sounds pretty simple, but it's a little complicated. So we'll go through a simple example. So a user asks a question, what is my average RPM for Walmart? Some of you may think, Walmart's not a car, by RPM, revolutions per minute, that doesn't make any sense. If you put the same question into Google, Google will think you're asking what is the average revenue per minute for Walmart Corporation. What is really happening here is we have a company that ships goods to Walmart, and they're asking about their average rate per mile on a weekly basis. So in order to track all that back, we gotta go through a sequence of steps. First, we're gonna have to we deploy what's called a tagging agent. They understand the basic context, understand who is talking, and then they call the next agent. So the entire sequence, think of it as like ordering system with tickets. And each agent does their own processing and hands it over to a next agent. And that way we have a chain of entities that are intelligent in their own domains. So in this case, tagger agent says, this is the type of person that's asking the question, and I really need to get to a context agent to unpack what's being asked. Then we come up with a formula that says we're actually asking about rate per mile. In order to derive the rate per mile, here is the formula that's needed. This data will come out of the following data stores that may be all over the place, and ultimately some additional information here. Next agent that takes over in our design is a SQL agent. Again, we're operating on very, very diverse data. It's not really a data lake, but a set of multiple data stores that could contain information in various formats and various locations, in some cases with various fidelity, and we need to deal with all that. And when we do construct interface queries with all those data stores, they could get really, really complex. So using LLM for that is pretty cool. Ultimately, when data gets pulled, we try to understand, would that user like a visual presentation of the data? Do you want to build a chart? Do you want to build any kind of graph? And then what is the additional explanation that's needed? Or are we missing anything so we can go back and refine this exact process? Then eventually data gets summarized, sensitized, and presented. So design relies on a set of agents that are each tuned. Each of the agents have a pretty good expertise and deep knowledge in a particular domain. So to do that, we have to fine-tune each one of them. Exact fine-tuning process, as you guys probably know, it varies family to family, and in general, it involves preparation of a carefully curated set of examples, and then it's running through a tuning process that does small iterative adjustments to neural network parameters that optimize model for examples. It's important to know that for fine-tuning, quality of data samples is much more important than quantity. Our experiments have shown that a smaller but better data sets perform a lot better than large data sets that are less organized with less scrutiny before they're created. And the reason this is needed, again, as I mentioned earlier, the linkage between the business knowledge and generic model allows you to synergize capability of those systems. Otherwise, you can't really accomplish those results. And ultimately, like maybe to quote Elon Musk, if LLMs would exist in Middle Ages and somebody would ask about relationship on Earth and Sun, the model would very confidently tell you that Sun rotates around the Earth because that's the common knowledge. But when you apply specifics of your industry, what is it you're trying to do in additional knowledge you have, the answer is going to be completely different. So that's a detailed example of how do we fine-tune our SQL queries. So I mentioned the examples of what they have, but the process is pretty much the same. You curate a large set of diverse and well-balanced questions. Then we have human analysts create sample queries that are used for training. Eventually, we go through a training process where we minimize error over time iteratively. And then we leverage strong language models for evaluation, of course, augmented by humans. The other interesting part that I think important for industrial application of this technology is ability to deploy it with a zero downtime. So your applications need to be designed in a way that could seamlessly accept a newly trained model and switch to it when it's ready. So as we moved along the path of development, it was very apparent that models come up all the time. New technologies come up all the time, data sets come up all the time. Every time you see something new on the market, there is new premise, there's something bigger and better. Sometimes it's actually true. So question of evaluating the new market offering became very, very important. So we tried using general industrial benchmarks to understand the performance of model, but again, not having that linkage between our narrow industrial use case and the general model capability kind of invalidate those benchmarking results. So we had to build our own validation framework that assesses performance of those models, specifically in our settings. Currently, our experiments show that ChatGPT-4 with fine-tuning works better than everything else in terms of accuracy, in terms of response time, but the lead is relatively narrow, so it's not that much better than everything else. Then, of course, hallucination control is something that's really important, that needs to be done. So to just walk through this real quick, we say that AI models hallucinate, but in reality, we want them to hallucinate. We want them to synthesize the answers, but we want those hallucinations or synthetic answers to be based on truth, not just assumptions that have no data behind it. And given their autoregressive token predictors, you want them to do this. So a couple of things that we've done here through a normal process. So typically, you got your instruction tokens, fact tokens, questions, all run into a context, you run through a model, it predicts the next token. Hallucinations happened in the output generation is overly reliant on your instruction tokens, so it's not taking into account your data that you're actually trying to give it. Or sometimes it's picking the wrong token. So we need to build a strategy to prevent and detect hallucination. These are the couple of things that we found to be pretty successful. We verified that fact tokens exist and actually populated. And then we cross-reference facts and outputs across AI agents to ensure consistency. So in an earlier example, I've shown you guys how once we retrieve the data out of SQL, we run it through multiple agents to provide different flavors of answers, they could correlate. So think of like you're a police detective interviewing multiple suspects. If there are witnesses, if there are stories check out, it's probably true. Then we inspect relative contributions to context token to generated output. And in some cases, some of the open source models actually allow you to track down which tokens are used, which ones are used, and what impact they're having. So if you're seeing multiple tokens are not being hit, you know you have a problem. So far, with the framework that we've built, it's important to assess the quality. So we're striving for query latency to be less than 30 seconds, over 90% accuracy, and zero hallucinations. At this point, we're way over 90%, and we're pretty confident that when we don't have a right answer, we just do not provide it to user, and we go back and prompt for more. So last slide is a lot of times people ask what's next. What do you do with this? So I believe we can empower logistics professionals to do their job better. Next question is that going to lead to job elimination? Our view is by providing people new capabilities, we allow them to further grow their talents and do more with what they have, find novel applications of their talents and be successful in what they do. So I have a couple of bullet points here. So obviously, we want to broaden our reach and address entire logistical foundation, more data, more complexity, be a little bit more prescriptive in what we do, kind of take it a level further. And longer terms, efficiency of transportation. I mentioned it's a super complex field, a lot of variables, like infinite number of variables, and they're all interconnected, which is why we're so excited about LLMs. And we'd like to augment humans on routine analysis and decision. All right, I think that's all I have.
Thank you so much.
My pleasure.